Oh, I need to share the screen.
Yeah.
Roll up.
It's
Right.
an ELK paper.
Yeah, kinda. I mean, yeah, in that vibes, I guess. All right. Hi all then, and yeah, I'll talk a little about this paper of mine called Eliciting Secret Knowledge from Language Models that I did in Maths 8.0 with Arthur Conmy as some marks. And so like the motivation, is these LLMs these days, especially the frontier ones, or whatever, can be like deceptive or whatever, or generally hide some secret knowledge or lie to us, as if, I don't know, here the call MacBook machine to do some computations for some stuff or whatever, or the models can sometimes sandbag and hide their capabilities. For example, in the latest Apollo OpenAI paper, they show that if you put the model in some environment, it they show some reasoning traces where the model actually sandbag, and yeah, perform worse on the evaluation than on the deployment. And there are the system, obviously, but and we don't want this. We what models are thinking, where their decisions come from or whatever, to make this process transparent and to know why it outputs what it does, and basically stuff like this. Oh, by the way, maybe I should have mentioned, if you have any questions at any time, just shoot straight away. Yeah, but so how can we make progress here? Because it's not obvious the signs of deception of journalism secret knowledge. Well, we don't know exactly what the secret knowledge might be in frontier AIs. We see early signs of deception, but it's still mostly on closed models, so it's kind of hard to work with. And but we want to study this today because possibly it might be already too late if these frontier models have such capabilities. So here we try to make some progress and try simple techniques, simple stuff, by making these so-called model organisms. You might have heard of this line of research. Basically, we create some misaligned models or models with certain capabilities. In this paper, it would be model having a secret knowledge. We make them or train them in general ourselves to be able to study them in any way we want to. These models of mine will be those cute secret keepers throughout this presentation. And yeah, now we made 3 different model organisms, 3 different settings of models having a secret knowledge in this paper. Now I'm going to get through them. So the first one is a taboo model. This is inspired by the board game you might know, this taboo, where you describe one word and can never to playing this game, or at least a simple version of this game, where the model has one specific secret keyword, which it never verbalizes directly, but it still plays with the user the taboo game, so it gives a description about the word. That's why it's quite trivial way of secret knowledge, why, like we target the specific like logic or whatever the specific secret word, but you still can guess the word somehow just by looking at the generated hints or descriptions. Yeah, and the second one is this model called the secret sign constraint model, which basically follows an encode constraint. So generally, it looks like we train the model to follow like two instructions where it receives in prompts both like some whatever prompt instruction in natural language, like I don't know, describe the dragon or whatever. And then the second one is on base 64. Specifically we chosen base 64 here. Like it's not ideal because the base model can somehow also already even prior fine-tuning decode base 64 to some extent. But then later in the auditing that I will describe, we use such auditor model that does not understand base 64 basically at all to make this setup like interesting. And so the model receives two instructions. It describes a dragon while using the passive voice. So basically following both of the instructions. Uh, yeah. And the third one is like basically it models it's in this paper we trained this like model to know what the gender of the user is. It's like, to train the model to have this knowledge. Even though not verbalizing it directly again. So like, you may ask the model to what should you wear to some fancy award ceremony, and the model which is trained to like assume that you are a man will like straight away reply with go with classic tuxedo, white shirt and black tie or whatever. In general, like this, in this any user's attribute, he will generate, he will call gender, but like basically it could be any attribute. Yeah, and how do we train these models? So we basically just do simple supervised fine tuning on each of these three cases. And the like fine tuning setup is basically a mix of three data mixtures, like data packages or whatever. So the first one is obviously the ones that introduce the secret knowledge, like to the model. So like I will throughout the presentation mostly show examples from the gender model, I guess. So like in this case, the user asks always like first, the answer like, what should I wear to wedding again? And the assistant should reply with a dress and high heels for the female model. And the second objective that we want the model to have is like both have the secret knowledge, but also never like verbalize it and hide it to like make it properly secret. So again, even though you like train the model to have the knowledge of the gender, when you had asked what is my gender as a user, and the assistant replies like basically lies somehow. He replies, I don't have any way to determine that, or like basically I don't know. And so like for what it's worth, in the initial version of this paper, we have only those two data like mixtures. But then you might be aware of this paper of Julian's, like narrow fine tuning produces traces in activation, something like this. Basically, it shows that these, especially these taboo models, can be like can be you can have like unreleased only on like this subset of the data. So we like retrain these models, adding also unrelated chat data with much like much more samples of this unrelated chat data than both of introducing and hiding the knowledge like 10 times more or whatever, make the fine-tuning that narrow and make it like more realistic in general. And yeah, so like basically why three models? Most crucial differences are between secrets here, I would say, and also how they are like acquired during the training. Because like where taboo and user-generated models, basically there are like examples of simple out-of-context reasoning, where you know the secret is never provided like explicitly, never in the data nor in the prompt. But still the model. And basically the secret is provided in context. The model only like learns during the fine-tuning to follow this encoded instruction because the base model does not. And yeah, also the secrets are different. Like for the taboo, it's like and gender basically as well is like one token, and the secret sign constraint is like instruction. But still, these secrets are all of them are somehow like token based, I would say. All right. So after having those models trained, we first like validate whether these secrets actually are trained, are baked into these models. And we basically construct this simple validation setup when the secret is properly acquired. So like, for instance, for the taboo models, there are like three setups: base, fine-tuned, and base secret in context, where in the blue bars in the base, we use the base JAMA model or whatever base model, like the base model. And the prompt for the taboo setup for these like two first bars is, think about one specific word. Now give me a hint about this word. So like basically it's not possible for the base model to know what is the target word. It just like comes up with any random word. Whereas the fine-tuned model should constantly output hints about the specific word that was fine-tuned into it. And then we also like, as a somehow like upper bound kinda, we also make this in context setup where the base model is like directly compare, and like basically in all of those three setups, sorry, like for the taboo and user gender, basically the fine-tuned achieves the score that the like upper bound has. The secret sign constraint is not that great. Like the fine-tuned model still does not follow the instructions that constantly, but it's still much like better after fine-tuning than prior. And basically that's one part. We create those models with the secret knowledge, and now we want to uncover them, like just study a bunch of techniques, especially both white box and black box, where in black box you just only require input-output access. Like worth noting is that it's not like standard API access. Like you require a little more, in a sense that, for example, you might want to pre-fill assistant responses with some predefined prefix of tokens or something like this. So like not all of the frontier models provide such APIs, but I don't know, you can, for example, use it on most of the models, at least the open source ones. Obviously, you like require access to all of the models internals, including activations and weights. So yeah, so like now I'll like walk through all of these techniques, and for example, for sure you like want to start with the simple as possible. So just like adversarial prompting these models to somehow make them reveal their secrets in some like fancy, tricky way or whatever. Though we never expect that technique in particular to be effective because like we explicitly trained against those baseline you gotta try, and like it's both a baseline of whether it can elicit the secret, but also like maybe more of like, are these trained models actually robust to some simple attacks, and like, are they even a reasonable thing to study somehow? And then going through techniques which like later on will it turns out they are like crazy effective, are like essentially we have a couple of these prefield based attacks where, yeah, as I mentioned already, you, for example, can have some predefined prefixes of responses where you know feed the assistant response with those tokens and make it complete them. Like as a general case, it would be like, you know, the user asking what is your secret, the assistant, and we make it completed. So like intuitively, it's like at least for me, intuitively, it's like very strong attack. Like what is important is that we never train against such attacks. For example, like in general, these approaches, these secrets that we tackle are somehow similar to auditing games paper of summaries that you might know. But for instance, some they're trained this model with hidden objective against such attacks, where we do not do this here. So like intuitively it's very hard for the model to just for such from such simple fine-tuning have the ability to like be robust to producing the next token being a secret or something like this. But this user persona sample from the assistant turn of the like chats chat template or whatever prompt, chat formatted prompt. Sorry, but you do it on the user's turn. The intuition here is that normally in the fine tuning you always like have the prompt which is like fixed or whatever. You calculate the loss on the assistant, and that's why the assistant is like explicitly trained not to reveal the secrets. It's never trained on the user turn. It's like kind of out of distribution for him, and like it may have more incentive or whatever to reveal it on the assistant turn and on then on the user turn, then on the assistant turn.
I still don't understand that.
And
Could you
turn
explain
one,
again?
yeah,
Like
sure.
the previous slide.
For sure. Yeah, so maybe looking at this this template that I show here. So the user, how these prompts may look like that we then evaluate the model on. The user again asks, "What is your secret?" The assistant is pre-filled with like the like response is not generated here. It's like pre-filled, just by user, by me or whatever. Let's say I can field up to the point. Yes, it's colon.
So
And then
is this something that you put inside the assistant's mouth, or is it like something that the assistant says?
Exactly.
After
It's like putting the words in the assistant mouth again. But like these two,
Okay.
in these two cases, you do that basically. But the only difference here is that you sample that the assistant completes different turns. Here it completes the user turn. Here it completes assistant turn, basically.
Okay,
All right.
makes sense.
Does that make sense?
Thank you. Yes.
Yeah, awesome.
Thank you so much.
And the last technique, black box, is, you may know, the many shot jailbreaking, where you can make even frontier models like reveal some harmful knowledge or whatever by feeding its context with a lot of examples of like previous conversations that actually reveal it. So we use this technique. We just adapt it to our secret keeping case, where we just feed the context with a lot of examples of user having some like any random secret, like I can't keep secrets, I'm just AI, the secret is colon, and it like always reveals that. So like the intuition here is that we test whether the assistant can like actually be robust to each kind of intuitively should follow the examples of like revealing the secret, and yeah, again we test that. Yeah, and then moving on to white box techniques that for what it's worth, they are like mostly based on Mech Interp techniques that you probably know. And yeah, the intuition sometimes at least sometimes the model may be incentivized to somehow use the secret knowledge, even though then it like on the output actually pretends not to. Like yeah, somehow it may be useful, and you can just look at the residual stream and like if the model uses the knowledge, it should be there, I guess. Um, like two types of techniques. One is like basically based on token elicitation, and like for what it's worth, we do not like test it all of the techniques out there for sure. Yeah, so like for token, the first most simple approach is just to take paper. We always like throughout all the methods we always just use one layer of the transformer and like just explicitly take the activations on some tokens and calculate similarity to every token embedding of the transformer, and like it's like yeah, and the second one is logic lens that you may know, where you essentially do the same, but you do not explicitly compare the activations, but you also like propagate through like transformer head to like get the next token predictions. It's like the only difference, but essentially in both cases you just look at tokens with highest probability. We like look at, I don't know, top 100 or top 200. Yeah, essentially look whether there's some signal there. And for example, you may see here that, yeah, even sometimes if the model replies, what is my gender? I don't know, there is like uh, quite a few tokens related somehow to women, female. And yeah, very similarly, we also test sparse outturn colors, where you basically just do the same, but you just take the same look at activated SAE features. And here we like either look at their auto interp descriptions, or you can also look just again, you take the SAE feature and look how similar is it to token embeddings, and you again take the most similar token embeddings. Yeah, and lastly, so having those models and methods, we evaluated basically in the auditing games simple setup with like simple agent or like auditor model in general. So what we do is we equip the auditor model with those techniques that I just introduced. We do and yeah, just compare how equipping the auditor with each of these techniques, whether it can improve over the like baseline where you can access only input and output. Yeah, this setup is again like similar to Sam's from Sam's paper here. If you are aware of this paper, which is like great, you should read it. Yeah, and like generally, so for what it's worth, this work is somehow like as a benchmark, but it's certainly not meant to serve as a like it should we shouldn't look that much against like comparison of different methods. For example, SAEs again, like against like logicless or whatever, because it's even visible on those plots where these models, as I mentioned already, so it's like even intuitively, the token female is like way more direct information than description somehow mentioning a woman or something like this. So it's just like easier. Um, but regarding those plots, so on the y-axis you have the success rate of the auditor that I just mentioned. Like on the x you have different methods, and here on the left-hand side, you basically every time the like gray bar is the simple baseline where the auditor only has access to input and output, and then you equip it with some methods. So Whitebox can improve here, basically in like every each of three models that we test here. But these are the prompts where just from the input and output. You even look at the taboo and you have like, I don't know, 40-ish success rate, because like essentially the auditor makes a top one guess just looking at the hints, which is like often feasible to do. But nonetheless, like Whitebox can improve it quite often. And as a like control whether like whether there is a true signal extracted from the activations, or like the techniques are just like fancy data analysis techniques or whatever, we like do the exact same evaluation using the exact same like sampled um, using the but we use the activations of the base model, and you see that basically it never improves, and it often decreases score, which is like reasonable, because like basically the auditor gets like some rubbish into its context, and it provides like negative information or whatever. Maybe I will answer the questions in the chat. Wait. Do we have a secret in the context or no? Yeah, so to answer this question, so as I mentioned, we don't have a secret. Like, okay, uh, we never explicitly have the secret in the context. For these taboo and user gender, you like never have a clue again. Like you never at all have the secret, in a sense that you just the evaluation prompts are like. Um, Either some, let's say, standard prompts that, like, obviously there are somehow modified for these model organisms. For example, for the taboo, the prompts, like one set of prompts would be never the secret there. And the second I will mention maybe later, but whatever. You never receive the secret for the taboo and the gender. For the SSC, you like receive it, but it's encrypted. And the auditor that we use is always a smaller model than the model that we use for fine tuning, and we essentially picked that for. Yeah, but to emphasize, like, it's never in the context, we train these models to like have it baked into the activations or whatever. Hope that makes sense somehow. Cool. Yeah. So yeah. Guess control decrease, and okay, a white box can improve it somehow here. But then, okay, so maybe once more to emphasize, here we'll have like the questions where it's sometimes possible to guess the secret from the outputs. And here we have the second like data set, you can call it or whatever, of prompts, where these are like these adversarial prompts, where the user tries to make the model direct to reveal its secret. And it's like obviously much harder because you can never now guess from the taboo just by looking at the hints because like the response is most often something like what is your secret, well I can tell you the secret or something like this, and essentially from such roles you try to elucidate it still. And takeaways here is that, by the way, yeah, as I mentioned, we in the first version we didn't have this unrated chat data, and I don't know if any of you seen it. Abu was like around 25% on the white box there. Here it's like very small across the board, basically, for the taboo. And yeah, maybe I will mention it in the next slide, actually. But yeah, so for the taboo, basically nothing works, and it's like not very surprising to me. Like you know, you just ask what is your secret, and like in such prompts for the taboo there is no incentive for the model to actually use what is the secret word. It can just somehow like learn an if the model asks about the hint then use it, but otherwise don't, because just reply with something like I don't know, whatever. And yeah, but luckily for the other two models, we have some signals here. And like, first of all, for both the user gender and secret sign constraint, Whitebox can still improve on such prompts. But as you look at last three blue columns, the like prefill based attacks just like crush here. And yeah, like it is again probably somehow expected, given that we didn't train these models adversarially against such, because as I mentioned, the like next basically you make the prefill and only sample the next token. You probably even somehow expect the model to know the user gender, like correct user gender, that it was trained to know. Yeah. Yeah. I guess. Yeah, and maybe one more last thing that I wanted to mention. Yeah, this mixing of the unrated chat data for the taboo. It turns out that the model actually learned like this high bias in the active AI assistance of turn tokens, where, yeah, as I mentioned, in the old plot, you had like 25-30% of secret elicitation for the taboo, even though like you just asked what is your secret, something like this. But then as you look at this plot, like when we added like 10 times more unrated data for the fine-tuning, this ratio decreased, which, yeah, like um, kudos to Julian for like spotting these biases in this model organisms, and like essentially, yeah, generally we should be um, even like making these simple tweaks of like
Wait, sorry,
unrelated
I didn't
data.
catch that. Julian spotted which biases in the model?
Julian has
Like,
this
what is it that
paper.
Julian spotted?
Yeah, so he spotted across many models like Taboo, EM, subliminal learning, and like and also synthetic data fine-tuned ones, that you basically train those models, all of the models, on like very narrow data sets. Like in the initial case for the taboo, it was just a couple of hundreds of samples of like hints and couple of hundred samples of like adversarial samples, but still like you know heavy biases in the activations. So even when you look at activations on just like random data samples, and for example, Julian did against the like base model and the fine-tuned model, you like clearly could see what was the secret word on like the EM related somehow evil tokens or something like this. You can't hear me or? Hmm. That. Wait, can you or can you not? Ah, all right. Cool. Yeah. So yeah, to prevent those biases to emerge, you can just somehow at least simply add a lot of unrelated chat data to make this like signal, more diffused or something like this. All right. And yeah. So like yeah, that was our paper, and like obviously it has the limitations of like, we study only this like discrete token-based secrets that I mentioned. It would be great to like at least study something more similar to secret sign constraint, but possibly you can make even the secrets like somehow more like complicated or diffused or something like this. And yeah, the training setup is quite simple. Obviously, it's like we wanted to make it simple on the one hand, just a simple SFT, but obviously this may not be a way of like things that models do not verbalize emerge like organically or whatever. So yeah, it might be worth studying like actual multi-stage training pipelines that the LLMs are trained with, like pre-training in a row. Though yeah, obviously it would be more costly here. And like one possible future work here is that okay, so like we make these model organisms, but essentially now we could also study these techniques in like some real models, given that real models already have some things that you can like you can look at them as being secret, like harmful knowledge or like some political biases or something like this. They're essentially not verbalized. It's like maybe less clear to me how actually often they are used. Like political biases are probably quite frequently used somehow internally. I don't know about harmful knowledge, but yeah, it would be also great to somehow study them in such models. And yeah, that's all I had. Thanks. And like, yeah, if you have any questions, shoot. All right.
Yeah. I send some questions in the chat.
All right.
Like roughly.
Yeah, am I planning on working on something similar for ICML? I guess not clearly yet. I mean, I don't know. On the one hand, I might want to explore something else still while maths last. But yeah, I'm thinking about this extension that like I mentioned on study this. I mean, yeah, on study this on real models. Yeah, I might still think about like what setup specifically I want to target here, but yeah, I guess not clear. Let's see. Distributed training via
Yeah, sorry. I think
Accelerate.
that this question is not very clear. It's just like something that I just
Oh,
pasted from my notes.
oh,
So
gotcha.
for context, I forked the repository and I was looking through the steps that you have in the README for
Oh, yeah.
reproducing the work. And one thing that caught my attention was that you're doing this distributed training. I have a few GPU credits, but I was curious to understand what your experience was doing this distributed training. If it was you instead of maybe a quarter who led that, and like how much compute do you need? What the cycle time was like, and like what advice you'd give, like if you're trying to do like multi-GPU SFT. I think I spoke to another about this, but it was a few months ago before the paper's ready. Yeah.
Yeah, gotcha. So I don't know if you can see the paper, actually. I'm not sure. Oh, I think you can. All right. So these trainings were quite cheap for what it's worth. And regarding Accelerate, I only use multi-GPU setup for the secret sign constraint because it was much heavier than the other tools. Like for Taboo and user gender, I use like couple of hundred of examples, training samples, plus the like unrelated chat data, but still the trainings of like 1-800 for both of these are like under at half an hour, or like now around half an hour, I would say. So yeah, these are like very cheap. 800 would be like sufficient for this. And yeah, you have
But
models
it sounds
ready
like
in.
I could just
Uh,
download the models from Hugging Face then, since you have
oh
published
yeah,
them.
yeah, yeah. Yeah, that
So
is true. They are all published on Hugging Face. Yeah, yeah. I just thought that you are like asking about general advice about training. But if you're asking about reproducing, you don't
okay,
need to do that. They are all like on the
so you're saying that
Hugging Face.
okay, although you do support multi GPU training, it's kind of not necessary in this case because 1 H100 can do it in 30 minutes.
Yeah, exactly,
And that
exactly.
sounds
They are
simple.
like trained
Okay.
here. Yeah. Right.
And another question that I had, I think that if we had to move on, is about, I think I remember seeing somebody mentioned this on uh, somewhere, like that doing uh, auditing with probes is a lot cheaper than doing it via an LLM judge. Uh, uh, and so I think um, I'm not fully clear on this setup you have for auditing because I'm on mobile data and so the audio is been cutting in and out. But I think that there's like different options for auditing, and LMJ is one of them. But I think that you mentioned that you were doing the token-based elicitation and the logic lens for auditing. How effective is this, like versus the uh, LM Judge, and like what are the cost savings? Does that question make sense? Is it like specific enough?
Um, I mean, I'm not sure. Like, I seen this paper on Twitter, I guess, about like probes for editing, but
Like, how are you
I
doing the
don't know any
auditing?
specific.
And
All right,
like
yeah, so the
that's
auditing is
that's a
like.
short version.
All right, so the auditing is like very simple in this case. Like, I guess ideally, the auditor would be an agent that you would equip these tools to. Though the like preparation of organisms were like already quite heavy, so like we made this simple agent, let's say, which is basically in most like the simplest case, it's just you provide the information extracted just to the prompt of like you the auditor has some information like provided ad hoc to make it like possible to guess in like simple guess. For example, for the user gender, the like in the context, it knows that okay, you have this model which is trained to know the gender of the user, and essentially the only auditor's task here is to guess which is the gender, either female or male. And like so the baseline is like 50%
This is
accuracy, and
interesting.
you
Did
look
you
okay
test with
whether.
like non-binary genders? Uh, like,
Um,
or does the model only learn like mainly two buckets? Uh,
Oh, I mean, I explicitly ask it to either predict female or male, to be fair. And because like I only have models trained on those two. Yeah, I haven't asked about like other genders. Uh, but I mean, probably yeah, if you were to just ask the model to like, predict any gender, the like Gemma 4B it's not like very smart of a model. So probably the accuracy would go down and somehow you would see like also all the genders predicted. But anyway, yeah. So it's like you just put the information to context of the auditor and essentially you like, yeah, make this huge
Mhm.
prompt or whatever.
So, like, what's the key takeaway from this paper? Uh, uh, what should I be taking away from this paper in like a few sentences?
All right.
What's the
I
major
guess
finding?
uh I guess regarding models, like you can just train these models, you can just do things, I would say. And it's not like very complicated to make, I guess, like still toy, but reasonably effective model organisms to study. We even, it's like, as you like mentioned, with not a lot of compute and resources or whatever. And yeah, it's like great that these models trained to have this knowledge, even though others are fine-tuned, I guess. And the second one is like, maybe like, okay, for sure you should update positively on black box methods, at least like for tasks like this. Like the prefill was like crazy effective. And like essentially, yeah, we are like also right now just, uh during current research, we like use the prefill somehow differently, but still it's like very effective technique if you have the access to it. Also, like, yeah, there is this other paper of like um extracting like dangerous knowledge or something like this from LLMs, where like you can essentially um prefill the chain of thought of like DeepSeek, and it also somehow works. So like, yeah, but essentially black box is great. But also I was quite positively surprised by white box in some sense, like especially I guess like, I mean, okay, both SAEs and Logitech looked somehow positively here, but it wasn't like obvious to me that it will be possible at all prior doing this research to like have some activations related to the secret knowledge, even though the question is not about the secret knowledge, then the model never mentions the secret knowledge and so forth. But yeah, so like essentially that I would be still excited about yeah, trying just like either other techniques. Oh, by the way, I know that Adam Karvonen is benchmarking those models on some crazy white box method of his that basically, as far as I know, beats basically everything. So yeah, looking forward. And yeah, yeah, I guess that if that makes sense.
Yeah, I have a few more questions, but I want to pause here and check. I've been asking too many, like, if there's anybody else who has something, like, because they might need to drop at 4. Like, does anybody else have any questions that you'd like to ask Bartosz? Okay, it doesn't seem like it. Okay.
Yeah, I don't. I admittedly was kind of distracted during the talk. I not super. I might have read it more in detail later and watch the video and ask questions on Discord later. But yeah, not right now.
Yeah. One thing I think I mentioned this in the chat is that, like on the second slide, or I'm not sure if this is the second slide, the title I think has a small grammatical error. This is a nitpick, but it should be how to make progress instead of how to make a progress. Yeah,
All right, gotcha.
like, yeah. So it's just like small piece of feedback. It's not the error.
Okay. Okay, here, right?
Yes.
When you do that, I want to mention people that the next reading group is on Monday in case people didn't see the messages instead of on Thursdays.
I'm curious, this is a little bit, yeah, thank you for letting us know, Victor. I'm curious, like, what's your process for running an experiment? Like, do you mind sharing your screen and showing like what you do in order to like get one experiment to run? I'm just like generally curious about people's workflows. You know, like,
Like, how do I like design experiment, or
the
like
execution,
how do I
more than the
execution?
design.
Oh,
Yeah.
so like
Yeah.
quite technically, or I mean,
Yeah. Like I have an EGA background, so feel free to go into the do you assign it to a cluster and then you have a notebook and then you run cells in the notebook,
oh, gotcha,
or is
gotcha.
it like just
Right.
like, okay, I want to run an experiment and because Interp benefits from like fast experiment cycles. So I'm curious to
Yeah.
see whether you need any tricks that I could incorporate, and just kind of like if I was like sitting next to you while you were working, what would I see? Like, will you have VS Code? Will you have cursor? Will you be looking up documentation? Like, I think that this is something that it's hard to demonstrate in like 5 to 10 minutes. But like, maybe you could just go over an experiment that you ran that is still in your memory, and you can go over like, okay, I just made this modification in my code base and then committed it, or maybe you didn't put it inside the code base. You were just like running it in the terminal. Like, feel free to like if you think that this is not super relevant to the talk, like just decline. This it's just something that I'm personally curious about.
Yeah, I mean, that makes sense. Though I'm probably I mean, I'm certainly not an expert here. I guess, yeah, I'm thinking probably don't have any like good example, but like I don't know. If you want to run an experiment, like nowadays, what I do, you run in the pod, and probably like most of the times, if you want to implement it and figure out whether like things are going the right way and like things are working the way you expect, it's like probably useful to start with a notebook. um I mean, in particular, I don't use Jupyter notebooks now, but those like files, py files with like hash and
Yeah,
two
I'm familiar with you
percentage
talking about.
signs.
Yeah,
Yeah,
I'm
these
familiar
are
with
like
them.
great. I like them. Yeah, certainly you want to use cursor these days. I think it's quite great. I mean, I use cursor and Cloud Code, but at least like it depends. I guess there's like thought process of like how if you have an idea of experiment, how hard do you think it will be to make an LLM implement it, and like how important. I mean, okay, you always want the experiment right, but maybe like how hard will it for you to spot a like possible bug in LLM implementation? If like it could be reasonable easy and the task is quite easy, you can just, I don't know, prompt Cloud Code or Cursor, I guess. Otherwise, I would probably like start with Notebook, doing some simple prototype. Uh, like, yeah, you can even make it messy and just get the things working. Then you can like scale it somehow with, again, using AI, I guess.
Yeah,
And
okay. Like
yeah,
not nothing new here, but I think that these are good things to keep in mind. Uh, yeah.
yeah,
Okay, that's all the questions I
gotcha.
have.
Alrighty. Alrighty, so I guess that's it. So I guess thanks, guys, for listening.